Welcome to The Explainer. Okay, so if you've ever written a basic script, you know it just runs straight from top to bottom. But how do we make it smart? How do we give that code a brain? Well, today we're diving into the tools that let our programs make choices, repeat actions, and handle whatever crazy things get thrown at them.
So here's the game plan. We're going to start with the straight and narrow path our code loves to follow. Then we'll learn how to add some forks in the road for making decisions, put in some scenic loops for repetition, and finally, figure out how to build detours for when things, inevitably go wrong.
All right, so by default, your program is kind of like a super diligent, but let's be honest, not very creative assistant. It just goes through your instructions, one by one, top to bottom. No questions asked, no detours taken.
This predictable step-by-step journey has a name. It's called control flow. It's the default set of directions. But the real magic, the real power, happens when you, the programmer, decide to grab the wheel and take control of that flow yourself.
Check this out. It's just like a simple recipe. The code starts at line 1 and goes right down to line 4 in perfect order. It defines new numbers, does a little subtraction, and prints out the result. We call this sequential execution. It's super simple, totally predictable, and it will always follow that same path.
But what happens when you need your code to actually think for itself? To react differently depending on the situation. Well, that's when we start adding some forks in the road, using what are called conditional statements.
And this flowchart right here shows that first, simple fork in the road. Our program gets to a decision point, that diamond shape, and it asks a simple question. If the answer is true, it zips off down a special path to run some specific code. If the answer is false, it just skips it and keeps on going.
In Python, that question looks just like this. The if statement is asking, hey, if I take this number n and divide it by 2, is there a remainder of 0? Which is, the classic way to check if a number is even.
And what's the result? Well, since 10 divided by 2 has no remainder, that condition was true. So the program made a choice. It ran the print command that was tucked inside that if block, and boom, it correctly printed even. It actually thought for itself.
Okay, but what if the condition is false? Sometimes just skipping a step isn't good enough. That's where the if-else structure comes in. It gives us a real fork in the road, providing our program with a plan B for when the answer to our question is false.
Let's see how it works with the number 7. So the question is this number even? Well, for 7, that's false. So the program completely ignores the if part and jumps straight to the code under else, printing out odd. Perfect.
Making decisions is awesome. But what if you need to do the same thing over and over again, maybe for 1,000 different items? That's where the real automation kicks in. Let's give our program the ability to repeat itself using loops.
And we've basically got two main flavors of loops. For loops are what you use when you know exactly how many times you need to do something, like going through every single item on a grocery list. While loops, on the other hand, are for when you don't know where the finish line is. They just keep running until some specific condition tells them to stop. A for loop is really methodical. You hand it a sequence, like a list of names or numbers, and it just works its way through, running a block of code for each and every item. Once it hits the end of the list, the loop is done, and the program just continues on.
And here are two really common ways to use it. The first loop is just going through a list of numbers that we've already defined, printing each one. The second one uses this handy range function to create a sequence on the fly, from 0 up to 4, printing each of those numbers in turn.
Now, a while loop has a slightly different job. It checks a condition before every single time it runs. As long as that condition is true, it'll execute its code. But the second that condition becomes false, the loop stops cold.
So in this example, the loop's whole purpose is to print numbers as long as our counter, I, is less than 5. Now this is super important. Inside the loop, we're adding 1 to I each time. If we forgot that step, I would never get to 5. The condition would always be true, and we'd be stuck in an infinite loop forever. The moment I becomes 5, the condition 5 less than 5 is false, and the loop knows its job is done. Okay, so we've got our loops, but they're still a little rigid. What if you're in the middle of a loop and you need to get out early? Or maybe just skip one particular step? Let's look at how we can bend the rules a bit with some shortcuts and emergency exits.
We've got two super powerful keywords for this. Think of break as the emergency exit. It just ends the loop right then and there, no questions asked. Continue, though, is a little different. It's like saying, skip this one. It just abandons the current cycle and jumps straight to the next one.
Take a look at this. This for loop is supposed to count all the way to 99. But we've planted a little trap inside, an if statement that triggers a break as soon as I hits 3. And as you can see from the output, the loop just stopped dead in its tracks.
Now let's try continue. This loop is set up to go from 0 to 5, but when I is equal to 4, that continue statement gets triggered. It tells the loop, hey, forget the rest of this cycle, which includes the bring command, and just jump to the next one. And that's exactly why the number 4 is missing from our output.
This actually brings up a really common problem. You know, you're mapping out a big if statement or a function, but you haven't written all the code for it yet. If you just leave it empty, your whole program will crash because Python's syntax demands something to be there.
And the answer is the beautifully simple pass statement. It literally does nothing. It is a complete void, a null operation. Its only job in life is to be a placeholder, to keep the syntax happy so your unfinished program doesn't fall apart.
Okay, finally, let's talk about the real world, because things don't always go to plan. What happens when our program hits an unexpected error, like a road that suddenly closed on its journey? These errors that pop up while the program is running are called exceptions, and instead of just letting them crash everything, we can actually plan for them using a try-except block. You can think of it like planning a detour. We try to do something, and if it fails, we accept that error and follow a backup plan instead.
It's really just a simple two-step process. First, you put the risky code, like trying to open a file that might not even be there, inside the try block. Then you define what to do in the accept block if a specific error happens, like a file not found error. It makes our code so much more resilient.
And this right here is the key takeaway. These aren't just a bunch of separate tools. When you combine conditionals for making decisions, loops for doing things over and over, and exception handlers for being resilient, you move way beyond writing simple scripts. You start designing programs that are genuinely intelligent and robust.
So, you now have the fundamentals for giving your code a brain. You can design the path it follows, complete with choices, repetitions, and backup plans. You're the navigator now. The only question left is, what journey are you going to build?